Hi, I'm Jan Ozer. I'm speaking today with Yoann Hinard, COO of Witbe, the Quality of Experience company. We're here to talk about Witbe's products and services in general, and specifically about a recent report that they published about the 2025 Super Bowl. Thanks for joining me, Yoann.
Thank you very much, Jan, for the opportunity.
So tell us what Witbe does.
So Witbe, we are a technology company specialized in doing test and monitoring. And our unique approach is that we behave like a user on real devices. So everything that we do, everything that we measure is done through real devices which are in territory in real locations. So nothing about emulation, about anything. We take what we call the Witbox, our product, and we plug using the HDMI any kind of real device from the smartphone to the smart TV in any kind of location.
Okay. And who are your customers?
We work with broadcasters and service providers. So the major broadcasters, which can execute either in the US, in Europe, in Asia, and also the service providers like Cox, Rogers, Orange, Vodafone, who are interested in the service that they deliver through their network to their customers.
Okay. And you talked about the Witbox. That's how you do it. What's unique about your product and service? Is it that you actually test the connections and the devices themselves as opposed to some kind of emulation?
Yes, our uniqueness is that we behave like a customer, which means that everything that is taken into account in order to improve the service, whether it is on the network, CDN, player, device optimization, operating system, dynamic ad insertion, progressive download, whatever you might think of if you are moving to a new transport like HTTP quit, everything that will be happening before the device can be measured by Witbe. We will see improvements or degradation of whatever can affect the user because we are using the real device, unmodified, very importantly. We do not touch at the operating system. We do not tool the application. And that means we can test any application, the store application, really as you would do yourself.
Okay. And what's a typical engagement look like for you?
Usually our customer purchase these boxes, spread them in their different facilities, or they can rely on us to host them in our facility worldwide. And after they choose what kind of test they want to run, if they want to just do manual remote testing in order to share the access to many of their different teams or partners. And they can be fully autonomous in creating the test case, operating the solution, and getting all the results that they want. And it's private result. If a company purchases these devices, the devices attached to them are their own. There is no device sharing because for security and privacy, they want to be able to load up specific build version of their application. They want to run in specific environment. So it's their data, their device, their application, and they choose how they want to use it.
Okay. So the Witbox, and you can show us a version of that connects directly to the device. It's got an HDMI pass-through. You can control it from the cloud once it's plugged in and working. What do you measure when you look at quality of experience? What factors are you monitoring and measuring?
So what we measure is from the end user point of view. So it will be timeliness, how fast the service is working. So it will be, for example, application loading time, initial buffering time, channel change time when we are talking about live TV, but also everything that can affect the service. So all the error code that can happen, a spontaneous crash of the device, black screen, frozen picture, error screen, sound availability, mono instead of stereo, specific closed caption which is missing, closed caption in the wrong language, pretty much anything that you could see as a user, including the quality. So we are measuring the quality non-reference based on what we see on screen in order to detect rebuffering, black screen, frozen picture, excessive macro blocking, to be able to act upon those and see how it differs from one version to another, from one location to another, from one device to another.
Okay, so you've got your own non-reference metric, or are you using a public one?
It's internally developed by Witbe.
Oh, okay. Do you have any correlations I mean, how does that correlate with any known metric like VMF or PSR or anything else? Have you looked at that?
So as VMAF is a full reference metric and it's really based on the degradation, it's not directly correlated with VMAF, but the correlation to user scoring is pretty good, especially for all the operations team who want to make sure that they don't have visual defect across. So we are focusing a lot on defect like excessive blur, excessive macro blocking, rebuffering, more than just, like VMAF, where you can use it to fine-tune your encoder to the frame or to the specific parameter that you would want to do.
Okay. So let's go to the Super Bowl. Why don't you bring up your presentation so you can walk us through what you did there?
Yes, with pleasure. So basically what we did, and at Witbe we used to do that a lot, and we do that frequently. We use our technology because it's non-intrusive to do some test and monitoring on events in the field. And for the Super Bowl, we use Witbox that we deploy at many different places. So here you can see a diagram of connectivity. So we use the HDMI out. Very importantly, HDMI was configured for the Super Bowl in 4K. So that means that the set-top box understood that the Witbox was a 4K screen with all the 4K features, 2160 at 60 frames per second. And the remote control is either through infrared, Bluetooth, RF4C, depending on the type of device.
Okay.
And we tested on a bunch of different devices, traditional digital TV, Spectrum, Verizon, DirecTV, also some virtual MVPD like Tubi, YouTube TV, DAZN, Fubo TV. And the methodology is the following. It's in territory, using real application, real customer account, no VPN involved, because we want to measure the performance as a user. Same type of devices. For the Fire TV, it was a Fire TV 4K and Apple TV 4K second generation. And for YouTube TV, we activated the broadcast delay option when it was available. So that means on the Fire TV and on the Apple TV. And the test that we do, so here you can see the deployment of the different devices in the different regions, East Coast, West Coast, Canada, and also some in France.
Can I ask a question? You talked about the delay on YouTube. What was that, and why did you enable it?
So in YouTube, they activated an experimental option that was made available, I think, something like 18 months ago, that they call broadcast delay. And from the user point of view, and when you activate it, you have a message saying it could potentially reduce your quality. It's at your own risk. It's an experimental feature, but it aims to reduce the end-to-end delay in order to be closer to the broadcast delay.
Okay.
So it's a user settings that is available for everyone. You just go in the settings. It's available on Fire TV, Apple TV, not on Roku.
Okay. One of the things that was widely reported about the Super Bowl as broadcast by Fox is that it wasn't native 4K. It was 1080p scaled to 4K.
Yes.
How did that influence your results? I guess you measured mostly latency, and I guess that really wouldn't have a big impact on those results.
We also did measure the quality and availability. In terms of quality as a users, between here we use it, even if it's a non-reference model, we did compare the results. And without disclosing the result right away, but Tubi did have a very good quality, even though they had a very good end-to-end latency. So it was indeed a very good success for them.
Okay. And what did you learn about the formats they used? I looked at some of your reports, and you talked about low latency dash, low latency HLS. Was that what most services used, all services used, any WebRTC or anything other than the low latency variations?
So here it was, on the results, it was mostly speculation about about analyzing the results. So just I think it will be interesting to just go through the results very quickly.
Okay.
Because here the protocol basically really goes in line with the results. So I'm totally fine with that. So here what we see is that we have seen that the results are different depending on the type of device and on the type of services. And we did not capture the traffic between the device and the network. And we did not we did not do any traffic inspection. It's something that is possible with the Witbe product, but that was not activated for this particular audit. So when we said in the report that yes, it's likely that they did use some low latency flavor of MPEG- and HLS, it's mostly because it's very common. So on Fire TV, it's usually MPEG- which is being used. On Apple TV, it's usually HLS. And we know from the industry that usually it's less common to have this low latency flavor properly supported on other types of screen like the smart TV. And for those, we think based on the results, because we can see a difference between multiple dozens of seconds between the fastest and the slowest. For sure, it was plain HLS or MPEG- with not particular fine-tuning of the segment size in order to provide a low latency. So our assumption is that it was their standard live configuration for the packager encoding and CDN with no specific low latency flavor in place for those who reached 20 to 40 seconds additional delay.
Did that translate to increased quality or?
No, unfortunately not, which is good for to be. They did manage to have a very good quality while having a very good delay. And we saw also that out of the list performer, we detected some loading errors. Because every 15 minutes we would retry to load the screen as a new user. We exit the application, relaunch the application to measure application loading time, replay the content to measure the content loading time, initial buffering time, and do a 15-minute session. And during that time, especially during the half time, we saw some increase in buffering and also some errors that were displayed on screen.
Okay. So any other key, those are pretty dramatically different results. You said no quality difference. Was there any quality of experience difference? The whole thing about low latency is you get concerned about buffering and the inability to manage any kind of slowdown in service. You didn't see any quality of experience minimization because of that latency? That was pretty consistent among all the devices you tested?
So what we saw was here. So I think here you can see the evolution of the initial buffering time that was measured on the Fire TV stick. So it's not quality of experience as for the average bitrate, but it's the time to load the stream. And it went from 2 seconds to 5 seconds, which from an event of that size is totally acceptable. 5 seconds to load the script, to load the service, and while having a very good quality, it's a very good performance.
Was there any? Were you able to determine where the stream was accessed from? Was there any difference that related to how the stream was being delivered to the service pre-encoding that could have caused some of those latency differences?
So for it could, especially because in what we saw that the upstream, so satellite, we had also a very good end-to-end latency for the satellite, which was measured in France. So depending on the transcoding process, it might have added some additional delay for some of the providers, the way they capture the feed, the way they receive the feed. where they are in the chain and how many transcoded was done before they received the contribution. But I don't think that it would exceed between 5 and 10 seconds maximum.
Yeah. Plus you don't really care. I mean, you're measuring the performance of the service and
yes.
What was broadcast latency? Were you able to figure out what that was?
So the broadcast latency, we use Spectrum as a reference in a totally arbitrary because it's one of the very widely used cable access. It's a traditional DVB-C, and it was the fastest during the days before the game. So Tubby was not at that latency before the game. It was not also on the next day. So that means they did something very specific for the Super Bowl. It's not their day-to-day encoding process and workflow. And the satellite in France was not broadcasting the same content on the day before. So this is why we chose Spectrum as your sport bar access, your neighbor access, and the thing where you should be quite close to when you're trying to deliver an OTT service that is really against the traditional cable.
Okay, and I'm sorry if perhaps I misheard you, but were you able to determine what the latency was? How many seconds behind the live feed, the actual live event, the cable was being delivered?
No, that's not an information that we had. We did not have anyone on the stadium and any capture being done directly at the camera level. We could have had. Let's say next year we want to work directly with the broadcaster. It's something that is totally doable. But for that, it was their differential analysis based on every screen available to the users.
Okay. So some of the findings that you reported online showed pretty significant differences in performance with the same service on different devices. Why would that be?
So our take on that is that it's first there is support of the device. So depending on if it's for all the sticks, Fire TV, Apple TV, and Roku, there are different support for the protocol. They are low latency flavor. The fact that, for example, for YouTube TV, they do not provide the option broadcast delay on the Roku makes sense that it's a device that is a bit less, not as fast as the other ones. And HLS is mostly favored for Apple TV, whereas it's mostly MPEG-Dash for the Fire TV. So the packaging and protocol and the way it's being supported and the support of low latency flavor is one of the indicators for the same service. Second one, and what we see also, is that smart TV is hard. It's not easy to deal with native smart TV application because it's very fragmented. We have a lot of operating system and a lot of variance in the millesime of the operating system. So if you take Samsung between 2019, 2020, 2021 up to now, it's not the same support. It's I would say it's even more fragmented than the Android base. Maybe not for the codec and everything, but for the way the application is behaving, the way the player is behaving, it's hard. And the second thing is that you can afford to ship a Fire TV to every single one of your developers and say, okay, if you have an issue, fix it, you have one at home. You will never, ever ship a Sony, a Samsung, an Hisense to every one of your developers. So it's harder to put everyone around the same table to see the issue, to fix it, and to improve it. Which is why also we designed the product that way, is to make sure that everyone involved can access the device they need wherever they are, even if it's a partner or a developer who is in Seattle and want to interact with the TV which is in UK.
Okay. Was this, out of curiosity, was this performed as an engagement with Fox, or was this something you just did for demonstration purposes?
It was for demonstration. So it was not, we would never publish the data that's as part of our engagement. Whatever benchmarking that we do as part of an engagement.
Yeah. I mean, I figured you would ask certainly before you. I was just curious. What would you, if you were Fox, what would you take? How would you use this information that you so graciously provided them?
Celebrate.
Right.
No, really. I mean, it was really a good job. So whatever they did on the, obviously some might say yes, Tubby is a free service, so a lot of the complex stack of managing account, user, right, and everything was removed and is not part of Tubby. But still, I mean, it's impressive. At first. This is not what I was expected. So first, yes, celebration. They did a great job. We have seen and measured that it's not day to day. The next day for the parade, it was 26 seconds after. So really, their day-to-day encoding, which is more in line with a free service, is not at that level. And it makes sense because there is also cost income associated with it. Cost to do low latency and income of generating a free service sponsored by advertisement. And after our take on that is that it's important to test and to control because you never know. It's extremely hard to guess. Guessing how it will be seen without seeing the device, it's extremely difficult. You can do every type of modeling, putting that in a AI, machine learning or everything. If you don't see what's happening, it's hard to just, okay, what happened if I turn on quick? What happened if I change that to that? How it would be supported? It's very, very hard to guess.
Did you measure drift at all? The difference in time between the different customers using the same device and service?
It was pretty stable. So because we the measurement of the latency was done very frequently. So the way it's working is that thanks to our partnership with Tag, we use their content matching. So it's really visual. It's looking at what's visually on screen at the different location, compute a fingerprint on that, and after compute the location of the fingerprints. Some of kind of like Shazam is doing for the audio. And the advantage of that computation is that you don't have to add anything in the stream. It's very resilient to changes, transcoding, rescaling, even a logo being added on top of the screen. It's totally fine with that. And it's only reporting the latency when it's a match. So in Canada, there is SimSub, which is replacing the advertisement, and it's okay. When it's a different content, it's not reporting garbage. And when it's in France, and obviously the advertisements were not the same as well, still. And we regularly compute the latency in between the streams, and we saw that it was pretty consistent. If you are like 15 seconds after, the variation would be between 1 and 2 seconds. Depending on the session, if you play the content, because every 15 minutes we would resume, go back. So from east to west, same, like 1-2 seconds maximum between the same service, East Coast and West Coast.
Did you notice any irregularities in the ad delivery? I presume they used either server side or server guided. Did you get any observations regarding that?
It went fine. For the ad, so in Canada they are substituting the advertisement, so which is difficult. I mean, sometimes they like to see the advertisement from the US, which have their own article on the next day of who invested on what to do which advertisement. But we have not seen, the service was not generating any dynamically added insertion. On the one that we tested, it was the real one from the production, so from beginning to the end, and it was all fine.
Okay, that was impressive. Thanks for sharing the data. What do you have coming up for NAB? I'd be remiss if I didn't ask you.
So we'll be at NAB. It's very important event for us. We will have a common event with TAG on their booth to celebrate this successful partnership. For the content itself, it's really around the virtual NOC, so the ability to provide every type of device to everyone involved in the delivery. And when we say involved, it's really to close the gap between operation field ops and also development QA. Because what we see is that when you can put the right issue in the hand of the right person, it's extremely fast to fix it. But doing that when something is very hard to reproduce, let's say, I don't know, any kind of service, streaming service, US-based streaming service that is delivered on an Orange set-top box or Vodafone set-top box, so Disney, Apple, YouTube, getting this box working in the US to put in the hand of the right developer to fix it can be extremely tricky. And even if you manage to do it, it will be going through hoops with VPN and things like that. And in the end, if it works here, you don't know if it's worked there. So just putting the right people around the same table working on an issue is really something that we are leveraging and that we continue to push. We have done many evolution on the product to make it more simple, easy to use, very fast. So we do internally use a very low latency, because when you want to take control of a device, it has to be immediate. But for that, we don't have scale. It's hundreds of users, not millions.
Okay. I'll stop by your booth and see if I can catch you in Las Vegas.
Yes,
Listen,
yeah.
Yoann, thanks for taking the time, and good luck at the show if we don't connect, and congratulations on a successful test.
Thank you very much, Jad. Have a great day.